A very good morning, students. In my last class, we have started the discussion on introduction to classical mechanics. And today we will be having the discussion in continuation with that. Uh, we have to discuss rigid and elastic bodies. Let me share my screen first and then we'll start. I hope all of you have seen and what I have asked you to do, few things in your surroundings, what we have discussed regarding the discrete and continuous systems. And if you are available with all those sorts of things as we have in my last class, and I requested you to look around with the links as rigid, flexible, and fluid. So I hope all of you have seen those. So I'm sure that you are seeing my screen now. So we will be discussing module 1 part 2, and this is second part of that, which is classical mechanics, introduction to classical mechanics. We will be discussing all these sorts of things. Already we have discussed discrete and continuous systems, but today our focus will be on rigid and elastic bodies, and then we'll move to constraint and then degree of freedom accordingly. So myself, Dr. Pradeep Sharma from University of Engineering and Management. Again, I am requesting you to note down my contact details so that in case of any problem or doubt, you can directly call me or directly message me. So we'll be having a small discussion on what rigid and what elastic bodies are. So you can see that rigid bodies are those where uh, mass points subject to the holonomic constraints, and we'll be having this discussion on holonomic constraints later in my class. But you must understand that this part, that the distances between all pairs of points remain constant throughout the motion. Suppose I give one example for this, like uh, just, just a moment. Suppose this is the mobile, okay, and I am putting one force in this direction on this mobile. So when I am putting this force on this mobile, so this is complete mobile is moving, okay. The complete mobile is moving. You are not saying I am not providing the force on this camera, the mobile camera, but that mobile camera is fixed on this device, so that when I am putting force on this mobile device, it is actually complete, the object is moving, okay. So this can be considered as rigid body, okay. But there might be another example like this. In my last class also I have shown this. This is the key ring containing one key. I am putting force on the key. So only key is moving. The ring is not moving. The ring is undisturbed. So I can say that this device, this complete object is not rigid. And again, I'm saying, taking one example. Yeah, this remote. So if I'm putting, there are different buttons on the remote, but I am not putting force on any individual button. I am completely um, applying force on the entire object. So all the buttons of the remote are moving in the same manner, in the same direction, in the direction of the applied force. So these type of objects where the distances between two pairs of points, whatsoever we consider in that object, remain constant throughout the motion, are considered as rigid bodies. And if there are n free particles, so there are, you can say 3n degree of freedom accordingly in that body. And for a rigid body, the number of degree of freedom is reduced by the constraints expressed in the form. So whatsoever means, if there are certain constraints or the restrictions on the motion of that object, so how many constraints we can create on that rigid body, that actually reduces the total number of degree of freedom. Now we will understand three parts over here, not three but two parts mainly. One is degree of freedom, what is degree of freedom, and what is actually constraints and holonomic constraints in that. So that we will try to learn. Here, this is the form. In this form, we can express Rij is equal to Cij. That is the available restrictions, and that is available constraints. So, rigid body versus particles, if we can compare, then um, particles are negligible. Means we are, you can say, we cannot provide force to a single particle because the size of the particle is very small, and all force act through the center of gravity of that particle. And we cannot consider that the rotation about center of gravity, so we have to neglect that. Okay, like a small particle is there. If we compare this with a small particle, so the force actually acts at the center of gravity, right? And the size is very small. But if the rigid body we consider, the point of applications and line of action of forces are important, and rotation and all moments about center of gravity are important, and we have to consider this because the size is now very large. So around the center of gravity, the forces create the moment and the rotation of the object that need to be considered here. So rigid body are defined in body space and transformed by the position and orientation into world space. So body space is actually that small segment in which we are trying to consider that. And then we apply all those forces, all those domain related information of that particular body space into the world space. Or world space, we can say the entire object can be assumed created by those small rigid bodies. Again, rigid body can be the extended body that moves as a unit, and internal forces maintain the body shape, and the properties are mass, shape, volume, center of mass, position, and center of mass, velocity, right? So whenever we are trying to push the force, like I have given you the example of this mobile, when I am putting the force on this mobile, suppose, so you can understand there is a sensor, there is a camera, there is a screen, all these parts are integrated into one device. And the forces inside that, if I put some force in this direction here, so it is not like that my finger is going across it, because there is some forces available on the surface which are actually resisting this force what I am creating on the surface. But if it is available on, suppose, a smooth surface like this, and it can move ahead. So if I am applying the force here, so it can go in that direction, in which direction I am applying the force. But the entire body is moving. It's not like that. If I am putting the force on the camera, so the only camera will be moving, right? So you can understand that I am not putting the force on the entire mobile, but I am providing the force on only on the camera. But because this camera is integratedly attached with this total device, so if I put the force on camera itself, then it will try to move the entire object. So that is the rigid body properties. And we can divide the bodies into two types, like rigid bodies and non-rigid bodies. And the non-rigid bodies can be considered as elastic bodies and plastic bodies. So we can easily discuss that what are actually elastic bodies. So we can understand that ability, or what we can say, to resist a distorting influence and to return to its original size and shape. When that influence of force is removed, so it is known as elasticity, right? But whenever this is not happening after the removal of the force, this is known as plasticity. Okay, so again I am taking one example. You consider this as actually the cover of my mobile phone. It's gel cover, and you can see its shape is intact. But if I am putting the force, I am trying to apply the force like this. You can see here, if I am trying to apply the force like this, then the force is applied and the distortion is done. Okay, but if I remove the force, it again regains its original shape. So this property, due to which objects regain its original shape after the application of the applied force, is known as elasticity. But there are certain things which we cannot say, like for example, this is a paper. In the same manner, I apply the force on this and try to change its shape. So if I apply the force, you can say here, I apply the force, so its shape is changed, right? So this type of property where the shape is not being regained by the object after the application of the force, after the removal of the force, it is known as plasticity. And you can understand that if any object is there, so there are certain forces from outside we are applying, and the forces from inside actually they are resisting that change due to the applied force. And this reason is for elastic behavior can be different for different materials. Like in metals, the atomic lattice changes size and shape when forces are applied. Energy is added to the system, but when forces are removed, the lattice goes back to the original lower energy state. But for rubbers, you can understand, or other polymers, elasticity is caused by the stretching of polymer chains when force are applied. So that's why uh, elastic behavior is being understood. And the important part to understand the elastic behavior, there is an important principle known as Hooke's law, and it simply states the relationship between the applied force and whatever the extension or distortion being done by that applied force. For example, here the extension of a spring. So there is a relation between the applied force and the extension of a spring is known as Hooke's law. And it states that whatsoever the extension due to the applied force is proportional to the force provided, the elastic limit has not been exceeded. So you have to see that elastic limit should not be crossed. Up to that point, whatsoever the force being applied, the extension will be proportional to that. And you can understand using this graph the force we are applying, an extension from a starting point to a region up to a certain region, which is known as elastic limit. Up to this point, this is you can say straight, and if we remove the force, the extension will come back. But this is the reason where the permanent deformation started to take place, and this is known as plastic region. So after this, within this green region, if the force been applied, the object will not regain its original position. and according to its structure, it will be fractured. If we are continuing to apply force beyond that region, it will be fractured. And different springs have different elastic limits, and Hooke's law is only true for a spring that has not been extended beyond its elastic limit. Okay. So if a spring has been stretched beyond its elastic limit, it reaches to plastic deformation, and after the removal of the force also, it cannot regain its original position. So you must understand that Hooke's law actually shows in a, you can say in a very good manner, that up to what limit we have to apply the force as per the elastic limit of different materials. So this is also extension of that. The stress and strain, the stress refers to the force available and the stress refers to the extension provided or extension achieved by the object due to this force or stress. And up to the point of this B, that is the elastic behavior, but up to this B to C, you can say, is the elastic limit. But after that, this plastic behavior is achieved C to D, and up to D to E, then it's the fracture point. So you can understand that every material has its own elastic limit, and up to what point we can extend it, that depends on its structure. So these are the mechanical properties of solid which you can consider, like stress and strain. Uh, Stress is restoring force divided by area. Strain is the change in configuration divided by original configuration. So using these concepts, we found few concepts of Young's modulus and bulk modulus, like that. So modulus of rigidity, Poisson's ratio, and relation between all these factors we can find. But this Hooke's law, if we say, is again this explanation, and elasticity and plasticity we can explain, and application of elasticity also. So all these factors you kindly go through, and I hope you can understand, but in a case of any problem you can discuss. So thanks a lot. We will be discussing the next part in my next class. And again, I'm requesting all of you to consider that in your surrounding, what are the elastic and what are the plastic um, objects available, and kindly see that what is their elastic limits, but do not try to um, provide the force beyond elastic limit, because then it will be permanently deformed. And if you again provide the force beyond that elastic limit, continuously force is provided, then the object can be fractured, or object can be permanently deformed. So it cannot be regained, and its original shape will not be achieved. So you have to take care about that. Thank you. So we will be learning the next topic in my next class. So thank you. Thanks a lot.